Okay, BC Calc kids, now we're moving on to Unit 7, Power Series. This is the essence of this course, all right? So what is a power series? Let's start there. Now, a power series is different than just a Taylor polynomial. Okay, a power series, number one, it's infinite. Okay, so you're going to have plus dot dot dot. With a polynomial, you will not have that. All right, so let's say we have the following. From n equals 0 to infinity, a sub n times x minus c to the n. A power series is going to have x in it, all right? Now, this a sub n is the rule that helps us develop the coefficients. So, a power series is a series in the form, now notice it's equal, not approximate, because it's exactly equal to a sub 0 plus a sub 1. Remember, these are derivatives, right? These come from derivatives divided by factorials. You know that. Okay, plus a sub 2 x minus c squared plus dot 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 plus a sub n times x minus c to the n plus dot dot dot. Okay, there's going to be a few series that you're going to have to memorize, all right? So let's just get that down right away. So you're going to need to memorize that the power series for e to the x is 1 plus x squared over 2 factorial, x cubed over 3 factorial, dot dot dot, plus x to the n over n factorial, plus dot dot dot. So you can write this out. This is the same thing as the series from n to infinity of x sub n over n factorial. Try it. Okay, so that is e to the x. Then you need to know sine x. Sine x is x minus x cubed over 3 factorial plus x to the 5th over 5 factorial. This is just an extension, all right? These are Maclaurin series. That means they're centered at 0. Okay, so c equals 0. That's what that means. Plus dot dot dot. Now there's an alternator, so it's negative 1 to the n plus 1. Okay, times x to the n over n factorial plus dot dot dot, because it's infinite. So we can also write that as n equals 1 to infinity, x to the n over n factorial. Try it out, you'll see that it generates those terms. Then you need cosine x. Cosine x is the derivative of sine x. We went over that in an earlier video. 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial plus dot 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 plus the alternator, negative 1 to the n, x to the 2n over 2n factorial plus dot dot dot. Okay, so this could be written as the series from n equals 1 to infinity, n equals 0 to infinity, of negative 1 to the n, x to the 2n over 2n factorial. Okay, if you try that out, that will make perfect sense to you. Okay. I need you to have this series memorized. We're going to be doing a lot in the future with this series. This comes from the formula, if you remember, from geometric 1 over 1 minus r. So r is your ratio. So this is 1 plus x squared plus dot 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 plus x to the n plus dot dot dot. So this is the same as the series n equals 1 to infinity of just x to the n. That's literally it for that. Okay, before I continue on, I just realized that on the first slide, I don't know when I make this video if it goes back to the first slide, but on the second problem, sine of x, when I had the sigma notation, it should have been -1 to the n plus 2 times x to the n over n factorial. Again, on the first page, sine of x is sigma n equals 1 to infinity, -1 to the n plus 2 times x to the n over n factorial. Please make that correction. When I wrote out sine to the x, I meant to index it at 0. So I'm going to fix this right now. I apologize. So that should have been -1 to the n times x to the 2n plus 1 over 2n plus 1 factorial. All right, so let me just fix it down here. So I'm starting indexing it at 0. All right, and that's just -1 to the n then, since I'm starting it at 0. All right, and then we just have x to the 2n plus 1 over 2n plus 1 factorial. Okay, sorry about that, kids. Okay, n equals 0 to infinity. So what you're going to be doing, all right, with these series is determining where they converge. You're going to be doing intervals of convergence. You're also going to be doing the radius of convergence, and you're guaranteed to have this on the AP exam. For a power series centered at C, there's 3 things that can happen. Okay? Exactly one of the following is true. Okay, either this series converges only at the center, okay? Now, all power series converge at their center, okay? Because that's how they're developed. Converge means they're equal. In this case, your radius of convergence is 0 because it only converges at the center. Okay, the second case is that the series converges everywhere for all x. For all x. So that, for instance, is when we have the sine x equals x minus x cubed over 3 factorial. That would converge everywhere. You'll see later on why. Okay, so what this means is that your radius of convergence is -infinity to infinity. So your radius is infinite. All right. Oh, this is your interval of convergence, excuse me. So the actual radius is infinite. The third scenario, the one that they're most likely to test on the AP exam because it's going to involve the ratio test, there exists some number greater than 0 such that this series converges for x minus c less than that number and diverges for x minus c greater than that number. And for this topic, you're going to be doing the interval of convergence. So the radius is going to vary here. The radius is question mark. Okay, the interval, we don't know any either, question mark. So you can see that this is going to be the most interesting scenario, right? So just remember, the first one, the radius was equal to 0. The second one, the radius was equal to infinity. And in the third one, your interval is either going to be c minus r, your center minus this value, or your center plus this value. And it could exclude the endpoints or include them. So what this means is that this is open into interpretation. You have to test the endpoints. This is why we learned all the series test. Okay? All right. So let's take a look at an example. Okay, so on the first slide I had mentioned that the interval of convergence for sine x, the sine x series was negative infinity to infinity, and the radius was infinity. Okay, so let me prove it to you. Okay, so sine x is sigma, right? Negative 1 to the n plus 1 times x to the n over n factorial from n equals 1 to infinity. Okay, so we're going to do the ratio test. So we're going to get the limit as n goes to infinity of the following. Now, because it's absolute value, I don't need to use this when I do my limit. So I'm going to get x to the n plus 1 over n plus 1 factorial. And then I divide by this. Well, when I divide by this, I multiply by the reciprocal, as you know. So this comes out to be the limit, okay, as n. Make this n stand out. As n goes to infinity, and then that's going to just become x, and then this is going to become n plus 1. Now, this limit has no bearing on x, so you factor the x outside. Limit as n goes to infinity of 1 over n plus 1. So this comes out to be 0, and by the ratio test, 0 is less than 1. Okay, so x times 0 is 0, right? So we get 0 is less than 1 everywhere. Okay, therefore, the radius of convergence is infinity, and the interval is negative infinity to infinity. There is an... Okay, pause your video and copy this question down. Okay, now as we know, this already converges at 3. Remember, it always converges at the center automatically. Okay, just reminding you of that. All right, so let's do it. So we have the limit. Remember, it's absolute value, so this negative 1 to the n isn't going to matter. So we're going to have x minus 3 to the n plus 1 over n plus 1 times 5 to the n plus 1. Then I multiply by the reciprocal because I'm dividing. So that's going to go in the denominator. This is going to go in the numerator. As n goes to infinity, n. Okay? All right, so this is going to all cancel. And we're going to have the limit as n goes to infinity of just x minus 3 over n plus 1 times 5, because the 5 to the n plus 1 is 5 to the n times 5, so the 5 to the n cancels. So that's everything I'm going to end up with. And I have times n from the second fraction, right? So now I can take out this x minus 3 over 5. That comes outside because the limit has no bearing on that. And then I have n over n plus 1. Well, this limit, you know, is 1. Okay, so now I have x minus 3 over 5 has to be less than 1. Okay, so when you're taking a look at this, okay, you could see that my radius is going to be 5. Now you can see it right here. Okay, so I'm just going to cross multiply by 5. X minus 3 absolute value is less than 5. So I need to think about the endpoints here. So I have to do the center minus the radius and the center plus the radius. And I'm not sure about the endpoints yet. That's where the fun all begins. Okay, so my center is 3 minus my radius. My center is 3 plus my radius. So I get -2 to 8 and question mark about the endpoints. So then what's going to happen is I have to go back to the original problem and I need to replace x with -2 and x with 8, and then I have to do series tests. Okay, so we have to test the endpoints. You want to do this in a very organized way. So we're going to test to see what happens when the endpoint is x equals -2. And then over here, I will test when the endpoint is x equals 8. -2, we end up with the series n equals 1 to infinity of -1 to the n, okay, times -5 to the n over n times 5 to the n. Okay, so now this is just going to come back down to algebra skills. -5 to the n, kids, is the same thing as -1 to the n times 5 to the n. N times 5 to the n. So these are going to cancel out. -1 to the n times -1 to the n is literally just 1 to the n. So 1 to the n is just 1, guys. So I end up with the series 1 over n, okay, from n equals 1 to infinity. Now this is a p series, and p is equal to 1. And when p is less than or equal to 1, it diverges, your series diverges. So this diverges. You can also say, by the way, on the AP exam, you can say that this is the harmonic series, which diverges. Sorry, I can't spell. Okay. Harmonic series, which diverges. Okay, that means you don't gain this endpoint. And if you do the p-series test, you have to say p-series diverges by p-series test. Whichever way you guys want to do it. Now for x equals 8, we're going to have sigma -1 to the n times 5 to the n over n times 5 to the n. So this is going to be an alternating series. So these cancel out. Now you may be tempted to call this the alternating harmonic series. However, this is not the alternating harmonic series. Okay, it's kind of dangerous to use these because you have to have the appropriate indices, all right? So the alternating harmonic series, just to remind you, is -1 to the n plus 1 times 1 over n, from n equals 1 to infinity. So it's not the alternating harmonic series, but we can use the alternating series test. Okay, so use AST. So how you would do that is you would say the limit as n approaches infinity, okay, with the absence of the alternator is 0, and the terms decrease in magnitude. Okay, so therefore, this series, n equals 1 to infinity, converges by the alternating series test. Okay, what does that mean for us? That means that the interval of convergence is -2 excluded to 8 included, because it converges at 8, but it diverges at 2. Now, the radius I told you was 5. The easiest place to see it is in that denominator there. Another way to see the radius is you could do 8 minus -2 divided by 2, because the diameter is 10. Okay, whichever way, I don't care so long as you can get it. All right, but the radius is 5. Second slide. Okay, one last problem. So let's look at this series from n equals 0 to infinity of x over 2 to the n. Well, number one, this is the same thing as the series from n equals 0 to infinity of x to the n over 2 to the n. Okay, so we start off. Remember here the center is 0. Okay, so next we get the limit as n approaches infinity of x to the n plus 1, absolute value, over 2 to the n plus 1, multiplied by the reciprocal, 2 to the n over x to the n. So remember, this limit has nothing to do with x. The x's are going to cancel out. You're going to end up bringing an x outside. Well, why don't I just wait? So you have the limit as n goes to infinity. This is going to be just x, because the x to the n is going to cancel. And in the denominator, you're just going to end up with 2. So you could see that this limit has absolutely nothing to do with this x over 2, okay? So the limit is literally just going to be x over 2, okay? Absolute value. You're going to make that less than 1. So you could see that the radius is 2. And we're going to have to look at the center, minus 2, and the center, plus 2. And we're going to check the endpoints. We're looking for the interval. So we need to check -2, and we need to check +2. So you go back to the original question. I'm going to use it from here. When x is -2, we have the series n equals 0 to infinity, -2 to the n over 2 to the n. Remember, this is the same thing as -1 to the n times 2 to the n. So those are going to cancel. So this diverges by oscillation. You don't have to do any test. Go check it out. You'll see that it oscillates back and forth, all right, between 1 and 0. Okay, now let's look at 2. So we just get 2 to the n over 2 to the n. Okay, so this is n equals 0 to infinity. So this just ends up being 1 to the n. All right, or you're just going to get a series of 1. So what's going to end up happening here is you're going to just have an infinite sum, right? So we could just say the limit of 2 to the n over 2 to the n equals 1. And then we can say that this series diverges by the nth term test for divergence. So you don't gain any endpoints here. So therefore, the interval of convergence is -2 to 2. Okay, and the radius is 2. All right, so we'll continue this in class. I think that's enough for this video. Thank you, guys. All right, kids, I realized that